First, I'm going to start out with our flagship product, VisualCAD CAM. We are running the latest release 2018. Now, feature detection can be performed on prismatic parts similar to the one that you're looking at here, or parts that do not have any sculpted surfaces or sculpted bottoms. So parts like these would work great, ideal for feature detection machining. Now, the features on these parts, ideally you would want to be working with a solid model where it's made up of poly surfaces and not individual surfaces. So you want to make sure the geometry that you're working with is a solid model. So once you have a model imported, could be a step file, it could be a parasolid or one of the solid file formats that can be imported into the CAD system here. Once you import in a model, you'd want to go down to the Features tab, which is under the Machining Objects browser. You could have the Machining Objects browser docked below the machining browser, or you could have it docked over on the side right next to the machining operations browser as well. So you'd want to go into the Features tab in the Machining Objects browser, and you will find Automatic Feature Detection. So when you select Automatic Feature Detection, it automatically analyzes the part and identifies all of the different feature types based on the geometry. So you can notice that in this particular scenario, you're seeing that there is two orientations identified, orientation 1 and orientation 2. So by default, for users who are running the standard configuration, there's only one orientation the features would be detected on, and that would be based on the orientation of the machine coordinate system that's being established. Now, if you're running the expert configuration, where the machine type could be 4-axis, the orientations that would be identified are in the direction normal to the rotational axis, so that would be along the 4 sides, your top, front, bottom, and back. So if you're if the rotation axis is defined along the x-axis, you would have the 4 sides normal to the rotational axis. If you have the orientation on the y-axis, it would be the 4 sides normal to the rotational axis defined. Now, in the case of professional and premium configurations, the orientations will be established for all 6 faces. So consider a box which has 6 faces. So if you have features on all 6 faces, it would identify features on each of those 6 faces, and it will list them as orientations 1, 2, 3, 4, 5, and 6. Now, on this particular part, since there are features only on 2 of the faces, one is looking down from the top, and there's a feature down on the bottom face, so there's only 2 orientations possible where you can identify features, and it automatically identifies the features on each of the orientations if you're running the professional or the premium configuration of our CAM products. So with the standard configuration, I would automatically identify the features that is normal to the machine tool coordinate system that is defined, or in this case the world coordinate system seems to be in the same orientation, and the machine coordinate system is in the same orientation as the world coordinate system. Now, once you have the features identified for each of the orientations, as you expand each of the orientations in the tree, you will see that there are different types of features that have been identified. We have planar face features, so as you select the feature in the tree, the corresponding features are highlighted on the graphic screen in the viewport. So we have a planar face feature, you have prismatic pocket features in here, and as you hover the cursor on each of the features, the depth and the feature information is automatically displayed as a tooltip. We now have hole features identified. We have chamfer features identified on the parts, and you can see that the depth and the angle of the chamfers are also automatically determined, so it makes your programming workflow a lot easier. And we also have open slot features identified in here. And we have hole features and planar face features identified for orientation number 2.